Welcome back, reinforcement learning. This topic is navigating with the Q learning. In this navigating with the Q learning, the one more topic in this navigating with the Q learning is introducing the Gridworld game engine. Okay, Gridworld game, we are explain the Q learning with using Gridworld game. Okay, in the last session, how to build the neural network for the Q function is explained for the Q learning, navigate with the Q learning. Now, in the Q function, implement the network for the Q function, we are using Gridworld game. Okay, in this Gridworld game, how to use the Gridworld game engine in Q learning. Okay, in this Gridworld game, it has the 4x4 grids. It has the 4 objects: agent, wall, pit, and goal. These are the objects. The aim of the agent or the player is to navigate these grids to reach the goal without touching the either pit or walls. Okay, that is the aim of the agent or player in this Gridworld game. Okay, in Gridworld game engine, it is provides the platform to understand the reinforcement learning concepts on this environment. Okay, this environment we have the 3 Gridworld game engines support 3 different initialization modes for the game board. This game board either initialized in the 3 modes. One is the static mode, player mode, third one is random mode. In static mode, here all objects means agent plus environment objects. Environment objects are wall, pit, and goal. Okay, here all objects including player all are initialized with fixed or predefined locations in static mode. Okay, player and all other environment objects must be fixed or predefined locations in this grid. That is the static mode mode of the Gridworld game. If the Gridworld game is initialized the player mode, the player starts at a random position. Okay, remaining objects means environment objects are fixed and predefined location. They are fixed at a predefined location in player mode. In player mode, player only start at the random position. Remaining environment objects are fixed at the predefined location. In random mode, all including player and all objects, the goal, pits, and walls are initialized at random positions. Okay, it is a complex environment. Okay, all are at the random position. They are initialized with the random position. It's some level complex to implement this one. So these are the initialization modes of the Gridworld game. The static mode, all are fixed positions. In random mode, in player mode, player only at the random position, remaining all are fixed position. Random mode, all including player, all environment modes also in random position. Okay, these are the positions, initializations positions of the Gridworld game objects. Next, setting up the Gridworld game engine. Here we are import the Gridworld from the Gridworld package. From Gridworld, import Gridworld, and game is equal to, we are instantiate the game is equal to Gridworld, size is equal to 4 and mode is equal to static. Mode is equal to static means the first mode, all objects initialized at the fixed and predefined locations. So size is 4. So size is 4 means it is a 4x4 grid. It is a 4x4 grid and the mode is static. So all are at the fixed positions. Okay, this is the game initialization. We are import the Gridworld game from the Gridworld, and it is instantiated with the size is equal to 4 and mode is static in this example. Now the game interaction, how the agent interact with the game, how programmer interact with the game. If you want to display the game, game dot display, the object dot display. Here game is the object of this class, object game dot display. Display the current state of the game board. The current state of the game board is displayed with the game dot display, and game dot make move actions, make move and actions. It mentions the actions of the game. Here the possible actions, we are mentioned the actions are in Gridworld game, the possible actions are U, D, L, R. U indicates up direction action, up direction, D means down direction, L means left side direction, R indicates move right. Okay, here the make move action, the make move in the game where the action can be one of the following U, D, L, R. And game dot reward, it returns the reward for the action performed. In this example, the possible rewards are -1 for non-winning moves, we got the -1, +10 for reaching the goal, and -10 for the falling into a pit. Okay, these are the possible rewards in this game for the actions. -1 for non-winning move, +10 for the reaching the goal, and -10 for the falling into the pit. So here we are using the methods display, game dot display for display the game, and game dot make move actions, you apply the actions, game dot reward, you display the rewards for the specific applied action. These are the interactions with the game. So for one example, the Python code for this for the Gridworld game, the game dot display, it display the game environment. Here game environment displays the arrays, the plus is object, and dot dot, and minus is the pit, P is the player, W is the wall. Okay, after that we apply the game dot make move D. So downside, downwards, down, move down, and game dot make move again D, move down, and game make move L, move left. Again game dot display, you apply the game dot display, the player is moved down 2 times. So this side, and that move left side. So the player position is here. Last one, we apply the game dot reward. Game dot reward is displayed -1. So the game is the player is move here -1 for non-winning moves. Okay, here all are non-winning moves. If you have reached the plus, that is the winning move. Remaining all are non-winning moves. That's why the reward is -1. So in this example, the player is moved downwards 2 times, and next it moved the left side. So he got the -1 non-winning move in this example. Here we have to, this is the game engine, game environment. So we have to implement this game using neural networks. So using neural networks, we give the game environment is a game state is the input to the neural network. So neural network receive the input from the environment state. The environment state is the position, the state of the game. Here we are using Gridworld game. It is a 4x4, 4 into 4 and 3-dimensional 4 tensor is the Gridworld game simulation environment. We are taking that. Here the objects are player, goal, plus is the goal, pit -1, and wall is W. So we have to give this game state input to the neural network. So in order to give that neural network, the neural network receive the input from the game state. In this game state, here 4x4 matrices. We have the 4x4 matrices. Each matrix represent one object. The one object means either the objects are either player, game, goal, pit, and walls. So the first matrix is the representation of the player. Second matrix represents either goal, third pit, fourth one is walls. So these are the positions of the here. The first matrix, the 4x4, 4x4 matrices. The first one is the player. Next one is for player, goal, and pit, and wall. So here the matrices contains either zeros and 1. So 1 indicates position of the object, remaining zeros other values. So here the player position is here. Here goal position is here. This is the pit position, this is the wall position. So each matrix represent one object. This is the player, goal, pit, and wall. Okay, using these values, these 4 into 4 into 4, 4x4 matrices 4 by 4 matrices we have the input. These all are given as a flattened, one dimensional flattened values. So 4 into 4 into 4, 64 values. We have the 64 values. These 64 values we have to give the we have to give these 64 values as an input to the neural network. Thus neural network implement the Q function that give the Q values, So this is the game, we represent the game state like this. We represent the game state like this. This is the game state of the Gridworld game in some, at the sum state. These matrices represent the positions of the objects like a player, goal, pit and wall. Okay, in this way, this is the Gridworld game engine. This Gridworld game engine we have to use to implement the Q function in order to implement the Q learning. The Q learning, the Gridworld games is the best suitable example to understand the Q learning concept in reinforcement learning. Thank you.